Welcome to Downeast Institute's 5th Climate Change Seminar of 2022. Thank you for joining us. My name is Hannah Green. I'm an Island Fellow for the Island Institute, and I've been working at Downeast Institute to assist with the education program, public communications and engagement, and some of the research going on in DEI's labs and in the field. This seminar is part of our series of Downeast discussions where we share some of the groundbreaking research being conducted through DEI at our facility in Beals and in the field around the state. This summer, we are offering these seminars every week during the lunch hour from now until August 16th. These seminars focus on how commercially important shellfish are being impacted by climate change and how to adapt to the changing marine ecosystem. For those that don't know, Downeast Institute is a nonprofit marine research laboratory, marine science education center, and shellfish production hatchery located in Beals, Maine, and Washington County. We also serve as the marine science field station for the University of Maine at Machias. Today's seminar will last about 45 minutes and is scheduled to end at 1 p.m. A few quick reminders. We ask that you please keep yourself on mute during the presentation. After the presentation is over, we will take as many questions as possible, and you can ask a question by either raising your hand on Zoom or by typing it right into the chat. And the presentation is being recorded and may be uploaded to YouTube for future viewing. And I will also be helping us today with the technology. With that said, we are really excited to share this presentation with you today on green crabs in Maine, the latest data from the Clam Recruitment Monitoring Network. Today, we're going to hear from Sara Randall. Sara Randall is the Associate Director of Downeast Institute. She has been conducting field studies to better understand the impacts of green crabs on clams and how to sustain clam production for almost 10 years. Her research at Downeast Institute focuses on how to adapt the clam fishery to the impacts of climate change. And with that introduction, I will hand the presentation over to Sara.
Thank you, Hannah, and thanks everyone for joining us today at this seminar. I'm really excited to be able to present this data to you, and I'm excited that people are interested in learning about what we have learned through the last 10 years. So this research that I'm going to be presenting today was collected in collaboration with Dr. Brian Beal, who is a professor of marine ecology at the University of Maine at Machias, and he's also the director of research at Downeast Institute, and I believe he is also on the Zoom today. So Maine has hundreds of acres of intertidal, and this intertidal is the habitat for softshell clams. And this is one of the most important fisheries in our state. It's associated with our state. We're the top producer of softshell clams in the nation. And it's sort of an iconic food staple for our summer months. And it is one of the top valued fisheries in the state in terms of landings, in terms of value, and also in terms of the number of fishermen it employs. And this is even in its current decline state because statewide clam landings have declined about 75% over the past 40 years. And when I say 40 years, for those of us that work in the marine science community, that will trigger us to think about what we know about the last 40 years. The last 40 years, the Gulf of Maine has warmed at a tremendous speed. It's one of the fastest warming water bodies in the world, actually. And so it's interesting that our clam landings have declined over the same period. So it coincides with that raising of the temperatures. And this chart shows in the green or the blue here, our landings of clams. And the red shows our average winter temperature. So January, February, March. And you can sort of see that as the temps here get warmer in the winter since the 1980s, our clam landings have really declined. We had higher clam landings like in the mid 60s to mid 70s. And that's the time period that we think of it, that is our like cool period, or what we think, actually, we don't even think of it as cool. We think of it as like what our temperatures used to be as, even though in the 1950s, we had a little bit of a warming period, and that's when people started to see green crabs and realizing how much of a problem they were, except then our waters cooled back down. So we just thought, okay, green crabs are gone, not a problem. We're forging ahead because we went into that cool time period. And in 2020, Dr. Brian Beal and myself and some other collaborators published some research, and in it we had this graph, and this is the mean sea surface temperatures recorded at the West Booth Bay Harbor DMR monitoring station from the time periods of 1940 up to 2018 or so. And we are looking, the red triangles are the decadal averages. So I was looking at this preparing for this seminar today, and I just wanted to look and see, thinking about that 1966 to 1974 period, our cold period, or a time period where we think of our fisheries as flourishing, and what that average winter temp richer range was for that time period. And I wanted to contrast it to what's happening in recent years in terms of our winter seawater temperatures. And so I averaged those together for 1966 to 74, our winter temperatures, and found that the average was 2.2 degrees Celsius, almost 36 degrees Fahrenheit. And then I looked at our most recent year, the most recent year available from that DMR portal was 2019. So I took 2019, went back the same amount of years, averaged those winter temps, and found that there was those average temps were 3.8 degrees Celsius, or about 39 degrees Fahrenheit in the winters. So that's a 1.6 degrees Celsius difference and almost a 3-degree Fahrenheit difference. And so I know that when I hear about the global climate change scientists, when they're talking about changes in temperature and what that means and what happens when we experience these temperature differences, they're very concerned about a 1.5 degree temperature difference. A lot of things can change. And then when I think about what kind of fisheries we had in this time period, the 64 to 74, that's when all our ground fish were flourishing. And then I think about this time period, and this is our, right now we're in a crustaceans world. So it's just really interesting to see that temperature difference. Now, I am originally from Freeport. Freeport is a highlining town for clamming and other fisheries. And I went away, as many people do when they're young. But when I came back to Maine, these are the kind of headlines that I was seeing. I came back around 2012 or 13. And if people remember, 2012 was the year that we now call the ocean heat wave. And that was at the time period where the problem of green crabs really came back into the forefront. The crabs became too large to ignore. Their impacts on the clams were becoming really obvious. And, people were very, very concerned about the impacts of the green crabs on the clam fishery. And so that is what led me, when I came back to my hometown of Freeport, to get involved with the Downeast Institute and a series of field experiments that we conducted in Freeport from 2014 to 18. And we wanted to collect fisheries independent data, because that graph I showed you before, that's landing. So that's fisheries dependent data. So I wanted to see what was happening independent of the fishery itself. And we wanted to look for solutions. We wanted to figure out how to mitigate the green crab problem, and also find ways to enhance commercial harvests. So from this time period, this 5-year time period, we did 26 field experiments at 81 different field sites. So in addition to the field experiments, we also did things like green crab trapping on 1 and 3 and 4 day soaks throughout the Harriseket River and the intertidal and the subtidal from May to November. We did a lot of clam protection with netting. We did some fencing projects, trying to fence off the green crabs, in addition to growing clams and upwellers and things like that. And so when we did our field experiments, we figured out how successful or not these experiments are by doing sampling at the beginning and ending of the experiment through looking at what's in the mud through benthic core sampling. And here's a picture of us getting ready to take experimental units off the mud. And we take these back to these samples or experimental units back into at a secure location where we process everything through a 1 millimeter mesh sieve. And that by process, I mean, we wash out the mud and we take what remains on top of the sieve and in terms of shellfish and other clam predators, green crabs included, and, collect those for calculating our results. And we could have used a 0.5 millimeter mesh sieve, but we literally did thousands and thousands of samples throughout this time period. So a 0.5 millimeter sieve would have been even more impractical than what we ended up doing, because during this time period of 2014 to 2018, we processed 36.5 tons of mud through these 1 millimeter mesh sieves to determine our results. Since this time of 2018, I have conducted more research, more field experiments across the state, including the Clam Recruitment Monitoring Network. So at this point, I am going to say that my tons of mud that I've processed is actually higher than this 36.5 tons. So one of the things that we developed during this time period in Freeport in 2015 actually was what we call a recruitment box or a Beal box. And so we realized that when we were doing our netting experiments and trying to figure out different densities that would work and different size clams that would work to grow to harvestable size, we were missing a key part of the population dynamics of what is happening with our clams. And we wanted to figure this out. We wanted to figure out what was happening at the earliest life stage. So right when the clams hit the mudflats, what's happening? So we devised this box that protects the clams that are settling out from predators. It's a simple box. It's got mesh on the top, mesh on the bottom. We often use a 1.8 millimeter mesh. It's called pet screen on the top. And this box is about 3 inches deep, and we array them on the mudflats like so in order to get an understanding of the clams that are settling on the mudflats. So how it works is that the clams when the egg and the sperm meet up, they turn into a larvae and they're planktonic. So they're floating in the water for 2 to 3 weeks in this stage. And then they settle out. And so they settle out. And so some may fall into our recruitment boxes, and they can easily fall into our recruitment boxes because when they settle out, they're only 1/5 of a millimeter. So they can easily fit through a 1.8 mesh. Now, some don't, they settle out over on the regular unprotected mudflats. But the ones that settle into our recruitment boxes, they're protected from most predators in this way so that they are able to survive and they are able to grow. And so through that, we can get a much better understanding of how many of the clams are actually recruiting to the mudflats, or we call them recruits. We also know that the crabs can get in because crabs settle out at 1 millimeter. So they can get in to a 1.8. And I'll talk about that too. This is what a really, really, really full recruitment box looks like once we remove it from the mudflats and take off the top mesh. And this was from Thomaston, and it's a record. It's the 3rd highest amount of clams we ever found in a recruitment box. So this is not a normal view, but it's a view of what can actually be occurring on our mudflats if we did not have the high rate of predation that we do. So we wash the mud out, like I said, and this is what we emerged in these high grossing recruitment boxes. So it's a huge, it's a huge amount. Sometimes it can be a huge amount. And you can see there's a diversity of sizes of clams and recruits. So we always take these off at the same time period at the end of the clam growing season. So when we see the different sizes, that triggers us to think about, what is happening with the timing of the spawning. And I'm going to talk about that in a second. So we can also find in our recruitment boxes when a crab gets in, devastation, because this crab this crab got in, they're secure boxes. This crab got in at a 1.8 or below size, and he got in the recruitment box, and he ate a lot of clams, and he grew. And so he grew so that he could not get out. But he was okay with that because he was getting a lot of clams to eat. So we can also find this. This is another example over here of devastation that we would find from clam recruits when a crab gets in. We also find other species. We found like 27 different other species that we've documented. These include commercial species, razor clams, quahogs, there's quahog down here, worm casings, and different non-commercial species of shellfish. So as I said, the different sizes of the clam recruits that we found in the boxes made us want to learn more about the timing of clam recruitment. So we devised, I'm just going to take a minute to talk about this experiment that we did in 2017 to look at the timing of wild clam spawning and settling. And because we know that sometimes we can get green crabs in our boxes, we also knew that when we did this experiment, we could learn more about the settlement patterns of green crabs. You can learn more about this research with more of the methodology on our website. But basically, we went into the east side of the Harrisicot River in an area that we knew to receive high levels of recruitment of clams compared to the west side. We learned that for 3 years in a row, this side received way more clam recruits than the South Freeport side of the Harrisicot River. So that's where we put our experiments. And we put these experiments were about 250 feet apart, and they're about 30 by 80 feet blocks. And so this is a schematic that we put out. So we did a staggered deployment of recruitment boxes at each of those 5 sites. So every 2 weeks, we put 4 boxes at each of those 5 sites. And we deployed them every 2 weeks from May 5th, so before clams started to spawn, till September 22nd in 2017. And this is a random array, and that's what each of the sites look like. Now, the boxes remain until November 9th. That's the end of the clam growing season. So whatever size the recruits were able to obtain or grow to that year, they will reach that size by November 9th. However, between that September 22nd and November 9th, we continued to take samples. We continued to take the benthic core samples of the adjacent mud. So these benthic core samples, we took every 2 weeks. We took it in a standardized way with our standardized core, and we took 5 sediment samples at each of these sites. And so you can think of this as a clam recruit survey. We also looked at the temperatures at these sites. And so this chart graph shows the mudflat surface temperature 1 hour after high water from the May 5th to November 9th. And so you can see that in 2017, this area of the Harrisicot River obtained its highest temps about the same time that we're in right now, like the early weeks of, this past week of the first week of August. That was the highest period, the highest temps back in 2017 as well. They got up to about 68 degrees Fahrenheit. And then by November 9th, when we ended, we are back down to 50 degrees. And just as a note, we had been taking the water temperatures at these sites, at this area, for the previous 3 years with our experiments. And this was actually a cooler year. So this is where it really gets interesting, because this graph shows the water temp in the blue, or the seawater temp, and the amount of clams that we found in our surveys. So this is in the unprotected mud. And you can see that when the seawater temperatures rose above 12 degrees Celsius, so about 53, 54 degrees Fahrenheit, that the densities of the clam recruits that we found on the mud declined. And they declined significantly. Before that, we were getting 4 to 6 clam recruits per square foot. at these sites, and then it dropped off, and it especially dropped off after, the beginning of June. And so this is showing us how much predation that these animals are, the clams are experiencing as they first settle onto the mudflats. And we know that the clams did actually recruit to the mudflats because we opened up our clam recruitment boxes at the end of the year and found numerous clams that had been protected, so they were able to survive and grow. So in general, from this experiment, we were able to understand some key concept about clam recruitment. So that clam recruitment began in mid-May and continued to at least mid-August, and that there was a peak in clam recruitment during the first half of June, and that's when seawater temperatures range from 54 to 60 degrees Fahrenheit. But that recruitment continued through mid-August and perhaps into September. But there's just not as many that are recruiting at that time. And recruitment, so that means that clam recruitment is skewed and protracted, not a single event, but that the clams recruiting to the flats before mid-July are subjected to intense predation and most die. And then here's another key concept, that there are areas of the mudflats, mostly in the low and mid, which is not coincidentally the areas that receive the most heavy predation, because that's the areas where the water is covering them, and that more often or more frequently. And so those areas are subjected to higher levels of predation. Those areas, sometimes people say that's dead mud, and they say, oh, we're just not getting recruitment there. But these boxes and our placement in this experiment and other recruitment experiments that we've done have shown that those areas are actually getting recruits. They're just not able to survive. So because of the high levels of predation. So we also found some significant things about green crab recruitment, because again, green crabs were able to get into our boxes. So green crab recruitment appeared to begin sometime between August 10th and August 23rd, when the largest influx of small crabs occurred in the boxes. And that the crabs likely continued to settle the flats throughout October and perhaps early November. And they can overwinter at sizes smaller than the aperture of PET screen. Should say 1.8 millimeters right there. And the success of overwintering crabs is the key to survival success of clams the following year. So the more crabs that can survive the winter, the more they're able to grow and survive that next year. And that spells a problem for clams, because the green crabs later settlement, along with their size difference. So green crabs settle out at 1 millimeter, clams settle out at 1/5 of a millimeter. This gives green crabs a life strategy advantage over clams. They're bigger when they come down. And when we have our warm winters, more of them are able to survive, and they're ready to eat those settling clams when they come down in May, June, and July. So while fewer clams settle to the flats after mid-August, those animals that are settling later are the animals that represent the bulk of those that make it to survive into the fall and winter. So those clams that settle late, even though there's fewer of them, those are the ones that are able to survive. And so those will become the commercial fishery in 1 to 2 years, because a clam can't grow to harvestable size in 1 year. We know that, in the Harrisicot River, we've seen clams grow to, when they're protected, grow to 1.5, or even once I found one at 1 3/4 inch, but they cannot make it to 2 inches in 1 year. So warming waters equals increased predation. And our fisheries independent data that we published in 2018 from our 2014 and 15 clam recruitment with the work with the Beal boxes in Freeport, and also some other experiments that we did in Wells and Portland, found that 99% of clam recruits are being eaten before they turn 1 year old. You can find this paper on our website. We've also found in subsequent experiments and experiments that we started conducting during that 2014 to 18 time period in Freeport, that traditional enhancement methods are no longer effective due to warming waters and predation. Things like brushing specifically, which we published in 2000, a paper we published in 2020 talks about that. And we did 3 experiments across the coast in Gouldsboro, Bremen, and Harpswell. And that other proposed solutions, like perhaps sediment buffering with shell hash, where the attempt would be to create a more favorable environment on the mudflat that wouldn't be as acidic. That also is not effective, because whatever positive influence it could have or would have is being masked by the levels of predation that we're experiencing on the mudflats. And we talked about 2 weeks ago at our Downeast discussion seminar, we talked about the results of those specific experiments. Dr. Brian Beal and Dr. Robert Holmberg talked about that. If you missed it, that is on our website. It's linked on the homepage. So that finally brings me to the establishment of the Clam Recruitment Monitoring Network, which we started in 2020 because we wanted to collect standardized data across the whole coast about how much clam recruitment is occurring. And this map, each of the orange dots represents our partner towns. So we have Wells, Scarborough, Brunswick, Wiscasset, Bremen, Islesboro, Frenchman's Bay, Beals Island. This is Edmonds, which we added in 2021, and then up top is Sabayak. These red stars are the towns we expanded to this year. I'm not going to be talking about the data that we have received from this, because we haven't analyzed that yet, because it's not the end of the 2022 clam growing season. But in each of these orange towns, we have 2 Clam Recruitment Monitoring Network sites set up. And that means we have 16 boxes at each site. And that all these are in the same intertidal gradient, so they're in the lower mid. So that way we can compare the data that we get from all of these sites to each other in order to figure out what is happening. And in Edmonds, we have three sites instead of 2. So the boxes are on the mud from May to November each year. And we are collecting information on mudflat temperature. We conduct spring baseline surveys to figure out what's there at the beginning of the year and see what their sizes are, what species are there, and how many. And these recruitment boxes give us a picture of clam and shellfish recruitment. And I say it's a picture because of the fact that we know that sometimes green crabs can get into the boxes. And so, then they're going to eat the clam, at least some, if not all of the clam recruits. So we also know that we can get green crab demographic information from these recruitment boxes. And then when we take these Beal boxes off the mud in November, we also take benthic core samples of the unprotected mud. And through looking at what's in the unprotected mud that's adjacent and comparing it to how many clams are in the recruitment boxes, how many recruits are in the recruitment boxes, we can get an estimate of how many of these clams that recruited to the flats actually survived. So just to give you an idea, because it is called the Clam Recruitment Monitoring Network, here are some of the densities of clams that we received in 2020 and 2021. And in general, our recruitment was much lower last year in 2021 compared to 2020. And Gleason Cove was our record setter back in 2020 with over 1,000 clams per recruits per square foot. But you can even see, so I couldn't even fit them on the chart because they're too high, but you can even see that they dropped off significantly in 2021 in terms of the clams that we found inside the recruitment boxes. So here are those numbers, but side by side, so a little bit easier to see. And you can see that in the majority of the cases, there is a decline from the average clam density from 2020 to 2021. And then Brian did a sign test about these differences and found that the overall change in clam recruit abundance across the nine, it says 9 sites, but it means 9 towns, was unlikely to have occurred by random chance alone. So this map shows the green crab densities that occurred in our recruitment boxes in the year 2020. So you can see that we are topping out here with the orange dots, and those were 2.6 to 5 green crabs per square foot. And our highest density occurred at one of our sites in Wells with 4.95 crabs per square foot. And up here in Frenchman's Bay, we had the lowest density. Now this is our 2021 densities. So I had to add a big red dot to indicate this larger density. And this larger density is encompasses everything from 5.1 to 16 green crabs per square foot. We had the most green crabs per square foot in Islesboro with almost 16 crabs per square foot. And we had 4 towns that had this high density. And so again, here's that same data, but in a way that might be easier to look at or understand. And so in all of our sites, when we look at all of our towns, when we look at them, we see that there was a higher density in green crab and with green crabs at all the sites except for 2. And Brian ran a sign test on those, and he found that the overall change in crab abundance across the 9 towns was unlikely to have occurred by random chance alone. So then I started looking at comparing the average green crab size. And, again, so this is the average size of the green crabs that we found at each individual site in 2020 versus 2021. And then this column shows if they increased in average size or decreased. And the majority again increased. And Brian ran that sign test and found that this difference in the average size of the green crabs from 2020 to 2021 was unlikely to have happened by random chance alone. So when I think about that, I think about temperatures, and I think there must have been something going on. We had less clam recruits, more green crabs, and bigger green crabs. So then I looked at our temperatures that we had for each of these individual flats, and look what I see. In each of the sites, except we had lost a few hobo temperature recorders, so we don't have any data at a couple, but at every site except for 1, in 2021, the average temperature at high tide for each site was higher. So it's all related to temperature. The more green crabs, green crabs are just able to flourish in these warmer temps. And we were also able to see a relationship between crab size and clams per box. So this is from 2020. We looked at all 18 monitoring sites, and we determined that there's a relationship between the number of clam recruits per box and the size of the largest crab in the box. So when a crab exceeds 10 millimeters, which is about 1/4 of an inch in carapace width, few soft-shell clam juveniles occur in recruitment boxes. And then we looked at the same thing for last year, 2021. And even though we're getting less recruits in the boxes, the pattern is still the same. So we can sort of say, looking at the 2020 and the 2021 data, that if the carapace width of the largest green crab in a recruitment boxes is between 10 and 15, like 15 would probably be the highest here, then it becomes more unlikely that any soft shell clam recruits will occur in a recruitment box. And that is significant because it's showing the amount of predation that is occurring, and sort of the effect of even the presence of one crab on clams. So this data and more can be found in these two reports that we published, and they're both found on our website for the 2020 and 2021 results. So I really encourage people to look at that. You can get a huge amount of information from for your local area, and it's found on our website under research for soft shell clams. And if you go on that page, if you scroll a little down, this is the link that you should click on. In 2020 and 2021, our Clam Recruitment Monitoring Network was funded by Sea Grant, so we'd like to thank them. And last year in 2021, Luke's Lobster gave us some funding to help us tabulate other commercially important shellfish, such as Atlantic surf clams and razor clams and quahogs. So we're able to add that analysis to our 2021 report. So to summarize, that the predation that is occurring and the force that is impeding our commercial harvests in Maine is happening at a scale that people cannot see. It's happening at a really, really small scale, like 10 millimeters and below. So it's happening, we can't see it. Even if we're clamming, you know, we're not going to notice the crabs that are like 1 millimeter settling out, or even 5. We're going to notice maybe a 30 millimeter crab or a 40 millimeter crab, but the devastation is happening when in the first year of life of the clams, and those are being eaten by crabs that are like a year or 2 old. And crabs never went away. Sometimes over the past 10 years, I've heard people say, okay, well, they're not as bad this year, or they went away. They never did go away. It's just maybe they're just not as obvious to people who are looking for these bigger crabs, or have their eyes peeled for the bigger crabs. They never went away, and I know that because we've done this analysis of the tons and tons of mud. We are continuing the Clam Recruitment Monitoring Network into 2022, and that's thanks to continued funding by the Maine Economic Improvement Fund. And so that's going to allow us to continue to collect information not only about clam recruits and how much they can grow and survive if they're protected from predators, but it's also going to show us some provide more green crab demographics. And this whole Clam Recruitment Monitoring Network, because it's standardized fisheries independent data, this is really going to be a key to, and can be a key to, evaluating future potential management changes. So example, if the state instituted a higher, a upper size limit or a lower size limit, you could evaluate the effectiveness or not effectiveness of the measure by using this 2020 to 2022 data, hopefully onward to whatever the data is after the management tool was implemented. So this is really key data to be collecting. It was modeled, or collecting this data was modeled after like the lobster settlement index. So that was sort of the concept behind that. And I would like to put a plug in for next week, our final Downeast Discussions Climate Change Seminar. It's going to be given by Ray Chaya, who is going to talk about another aspect of his work, which is using meta-analysis to explore the roles of upwelling exposure and experimental design decisions in bivalve ocean acidification studies. And it's going to be held on the Tuesday at the same time period over lunch. And just contact me and I'll send you the link. And with that, I will end my presentation and take any questions that we have time for.
Sarah, I have a question. First off, thank you so much for your presentation. I've been eagerly waiting to see the results of last year's study, given that you presented to our members and they're looking forward to seeing your results. So thank you. And my question is, in this year, in addition to rising temperature having a significant impact on green crabs, it's beginning to appear that just the warm temperatures may be having an effect on soft shell clams. And I was just wondering if you had any data from this year on the temperatures you're seeing in the mud flats, because we're seeing, like in McCoy Bay, when we put a sonde in the water, in the channel that goes into the bay, we are getting readings over 80 degrees Fahrenheit. And I'm just wondering what you're seeing in the flats, and if those temperatures alone are having an effect on the health of soft shell clams that's compounding the effects of green crab predation.
Yeah. So Ivy, that slide where I compiled the cold years to the warm, that was for you. I was going to send it to you after the presentation, because when we talked the other day, you triggered me on looking into that a little bit. But yeah, so we don't have our data from 2022 in terms of temperatures at our sites, because we use hobo temps that are stuck in the mud next to our site. So I don't have any of that data available now. And I know I know a little bit about what's going on in McCoy, and I'm not sure. I was looking for Brian to talk about like the clam temperature, the temperatures that they can live in. And I know that that's a concern about what's happening in McCoy, but I don't have any answers to say. And I think, the proper answer is to say that we should design an experiment to test and see, to test that hypothesis that they are dying because they're outside their thermal range, and that's what's killing them. So sorry, I don't have a really good answer on that.
Thank you. I mean, I think certainly the experiment is a good answer, and it's concerning if 99% are not making it to survival, anyway, thank you.
Yeah. Yes, we don't want the adults to be dying too.
Do you have a sense over the longer term about the green crab population and its average size? Are there more, and are they bigger?
So what it appears to me over the last 10 years that I've been studying it is that their size is impacted by the water temps from like the previous year. So I see that connection when we have a cold winter. A cold winter will result in seeing more smaller green crabs. A warmer winter will allow us later in that summer or whatever we'll notice more bigger green crabs. And that was like really the situation in 2012 when we had the ocean heat wave. And then those animals were like wicked big, hard to ignore at that time. So I see that connection, and I think here and there, I think for green crab sizes, you would piece together to look at that. You'd like piece together like any data. Like I know Dr. Brian Beal has been doing research on this for 30 years. So you would have to sort of go back into his different papers that he's done throughout those years and sort of, you could like get a sense of it through that. And there's probably some other sources but it would take some compiling as far as I know.
To sort of frame why I was asking it, I'm in the fertilizer business, and we buy crab meal and we buy fish meal. It sounds like unless we can cool off the ocean, we're going to have more green crabs and maybe less clams. Is there any prognostications about when there's actually a commercial value to green crabs?
Right. So when I was doing the trapping in 2014 and 15, we had hundreds, if not thousands of pounds of green crabs we were trying to get rid of. We couldn't get rid of them. So this is, we had to donate them to somebody that had a large commercial fertilizer area. We also, so, or compost, excuse me. So, you know, I don't know. I mean, obviously, like the size is an issue, like you know, you'd want, you know, the biomass there to make it worthwhile. And so back in, you know, 2014, 15, we were trying to get rid of it. There were people at that time that were trying to make a business out of it, but they ended up, you know, having to take it down south for processing, and they needed to fill up their tractor trailer trucks in order to make the profits work. And they were having a hard time filling up their tractor trailer trucks.
Well, no, and that's precisely why I'm asking. Right now, if you were to buy them, they would cost about the same as lobster to harvest. So there's a point where someone does invest in filling tractor trailer loads and having it be a disposal problem instead of a look at them, they're eating our clams. So anyway, and I'm kind of off task for the purpose of your presentation, but on the chance you had seen some projections, I was curious.
Yeah, I mean, that's basically what I can tell you, the information I know.
Okay, thank you.
So Hannah Vogue asks in the chat about, you know, the struggle to figure out ways to mitigate the impacts of green crabs and the warming waters, and especially given that our waters are projected to continue to warm, and we're hearing about how warm it is this summer. And we actually had a warm winter this past winter, as Ivy knows, and other people that look at our winter water temps. So Hannah Vogue is pointing out, yeah, you know, the clams, you know, how are they going to survive? What can be done, and what other ideas are circulating that could help? So at Downeast Institute, because we've been studying this for so long, we sort of advocate for, or our idea is that, okay, we cannot get rid of the green crabs. Even if we trap them, you know, we're only getting the big ones out. It's the little ones that are doing the damage. So what can we do? We have to adapt to their presence, especially given these projections that we are going to continue to warm. You know, there are ideas that if so one idea is that we do intense husbandry. And so intense husbandry would be like aquaculture, and it would be people in areas where maybe there's less milky ribbon worms, you know, protecting discrete areas of the mudflats that are void of commercial clams, where, you know, in the low or mid intertidal where there's heavy predation, but the clams also grow faster. So allowing people to take on doing those would help sustain our clam production, perhaps. People sort of tend to have more, and the idea is to give the people like discrete areas, because in that case, people tend to, if it's theirs, they'll tend to put more effort in it, because they can see the direct results of their efforts in terms of harvest. And then another idea, so we got to adapt to their presence. Intensive husbandry, allowing people to protect areas in the mudflats from predation, or different management methods that could be implemented on a statewide basis, such as allowing, like what we do in other fisheries where we protect the larger breeders. And we've done some preliminary studies that indicate that clams are not senile as they get bigger. They actually release more sperm and eggs as they get bigger. And so why don't we protect those bigger ones and put an upper size limit on? And so maybe that could help us, because the other technique besides intensive on the ground predator protection in these discrete areas would be to see what can we do to swamp out predation. So in areas, so the idea would be to allow so many clams to settle that they could swamp out in areas, probably only, but they could swamp out predation. So they could allow so many, this is probably like the technique that clams have used always, that they could usually always, that's why they're recruiting in such high levels. They always could, you know, before green crabs were a problem, they could swamp out predation. And maybe if we put an upper size limit on and allowed the breeders, the larger breeding stock to stay, that maybe that could help us swamp out predation. So those are the two main like avenues that we think of. as ways to be able to help sustain our clam production. So Noah asks if I can explain why clam recruitment after mid-August has a higher survival rate. It is because our water temps start cooling a little bit. So like it lessens the pressure on the clams. And yes, so it is. And so he says, is it because most green crabs are too big by that point to predate on the smaller crab recruits? So yeah, there is an aspect of that going on as well, because, you know, who's really interested? If you're like 30 millimeters, are you really interested in a 1/5 of a millimeter, something to eat? Or are you looking for something a little bit bigger? Because you can handle something a little bit bigger. You can kill something a little bit bigger. So you might not want to fool with the like 1/5 of a millimeter. You're looking for something bigger. So there is that going on as well. So there's those couple different dynamics happening. It's really complex, and I'm really thankful to have had like some time. Usually I'm giving like a 10-minute or a 20-minute presentation. So I'm really excited to have had time where I feel that I can more adequately explain these dynamics that are occurring on the mudflats. Are there any other questions?
Is this an ongoing program? Will there be more years of data coming up?
Yep, we're doing it in 2022, this the Clam Recruitment Monitoring Network, and we actually expanded in 2022. And then in Maine, we expanded to 3 additional towns. And then if, you know, because it's not enough, we expanded into 4 locations in New Brunswick as well. So we're gonna have data spanning from Wells, Maine to Little La Pro, New Brunswick in 2022.
Are there any predators that eat green crabs?
Right. There are, so they're invasive. They don't have natural predators, but yes, ducks will eat them. You know, seabirds will eat them. They will be eaten. It's just, it's, you know, their fecundity is so overpowering that there's just so many that it doesn't seem to be making a dent.
Okay.
Okay, Amanda Lyons wrote in and said that green crabs are hard to market. It's expensive to process because there's a new product. Large composters don't want to pay more than $7 a yard due to water weight. Oh, okay, so she's writing in about some aspects about clam composting, or so with a trap design, choke holes, gas costs, and time invested while using broken clams as bait, it would need a clammer would need to clear, you know, 30 cents a pound to make it worthwhile. So maybe aquaculture could be a good way to place to market green crabs. Thank you, Amanda, for that comment. Yeah, the cost of making it cost efficient for or cost effective for the fisherman clammer, whoever is going to be trapping it, you know, is a key to developing that kind of market.
In my experience, unless you find a way to make chips out of them, if you're competing with fish waste that they oftentimes pay to get rid of, it's an inherently uphill battle unless you can add value to them beyond its fertility.
Yeah. Awesome. Well, with that, I will conclude the seminar. Please join us next week to learn to learn more about commercial, the impacts of climate change on commercial shellfish. And I really thank everyone for joining us today.